Here's our classic Samsung. Models in the description below, because I'm not reading it right now. So there's the model number. And it's got a classic problem where it just doesn't turn on. So here's our red light, and I'm going to hit the remote, turn it on. Blinks once, and that's it. So this one blinks once. Let's try again. Blinks once, and that's it. Okay. So let's try and get this one taken care of right away. So I'm going to do a quick tear down of this right here on the bench, and we'll take a look at what's inside. Okay, so here it is, the troublesome area with most of these Samsung TVs. And there they are. And I count again 1, 2, 3, 4, and 5 and 6, 7 and 8 capacitors, and I'm going to replace, even though these other 4 are not bulging. Out they go. I don't want to get married to this particular TV, and the caps don't really cost that much, so they'll get their money's worth, and it won't be a $260 something odd repair. And I'm not going to tell the customer, hey, I replaced the board, when I really didn't. So everything else looks okay. A little dusty. Of course, the high voltage caps, as normal, look okay. I've never seen these go bad yet, at least not in one of these Samsungs. Show you. So we're going to go after these guys. 1, 2, 3, 4. Pull these out first. Let's take a look at the value while we're here. I've got a 470 at 25, and let me guess, another 470 at 25 perhaps. Yep, another one. These two, 470 at 25, and these are probably 2200s. We got odd values on these. These are rated at 820 at 25 volts. Kind of surprised to see 25 volters in here, actually. In case you haven't guessed, I like to use liberal amounts of flux. Helps them come out nice and much faster. Oh, look at it wick up right there. No problems. Pop the legs up. Push down a little bit. Give it a yank. There it goes. Right up. case you haven't guessed, I like using this chisel tip edge because it gets underneath the legs of bent pins rather nicely, and I can pop things up and out right in a jiffy. So let's just go ahead and put these on the meter. An old capacitor meter here. So this here should read 820. 342, 344. Not good. Definitely not. And what we got here? Another 820 at 25 volts. About the same thing. 376. Definitely a baddie. So, as I've been going along, I replaced, well, these two. Didn't have 820s at 25. I did have 1000 at 35. So, that's what I put in there. And they stick out a little bit much, but it's okay. It's perfectly fine to use. Well, those arms didn't get in frame there. There they are. So it's perfectly fine to use capacitors like this that are overrated for the job, especially in a when they're being used as filters in a power supply. To jump from 820 to 1000, there's no problems there. The only time you need to really stick to the exact values if it's being used in a timing circuit of some kind. In this situation, it's no matter. So one of the other caps that didn't measure bad, but I've replaced anyways, this other 470 or no, was it 47? Yeah, so 47 mics, and that was rated for 50 volts. I didn't have 50. I put in the 100 volt. Again, if the voltage rating on the cap is the same or better, in this case it's much better, then that's fine too. You can go ahead and put it in. So, and this guy is next. And also these two. Let's get back to sizzling here. Ooh, what a lovely little crackling sound it makes. Well, so there's a 470 at 25. New good. And the other one here. Where are the pins on that? Here. Yes. Okay, so this guy. You can buy these capacitors from a number of different places. I have bought them off of eBay. I don't usually recommend buying there because you don't know exactly what you're going to get. And pictures can be very deceiving. And you should not go by the pictures. Always go by the values and the sizes. DigiKey is a good source. Mauser is a good source. And try to buy quality brands like this here. You can, We'll get in close. See that? It's a Nicholson. They've been making capacitors for a very long time, and they do a good job at it, and they don't fail by blowing their tops. So that's my little rant on that. And these are going to be replacing these guys, and you know, this here is going to be replacing this. So yeah, it's much bigger, considerably bigger, but we'll make it fit. Because guess what? I don't have 35 volt to put in there. I wish I did, but I don't. And there's usually room enough in these circuits to make something fit. Look at that, just fell right into place. Not a problem. Let's fold these pins over for a bit. Get the other one. I apologize if I keep going out of frame. I'm not consciously looking at the phone every 2 seconds, so my apologies. Alright, so this is going to be a little more of a bit of a squeeze. Not too bad. Don't get freaked out if your capacitors are not sitting exactly straight up. It's, you know, it'd be nice, but it's not absolutely necessary. If you like, you can always push down after you hit it with a little solder. I'll show you. Push down on one of the pins, see if we can get this to sit straighter. So we'll lump a little solder on that. We'll get underneath it and push up. Hit the other one. The other trace. There we go. And we'll be right back. Also running low on solder braid, so it's time to order up some more of that. I like to use solder braid that has a little bit of flux impregnated into it. It was full when I started, and I've used other rolls as well. Doesn't always get used a lot. We need to do a lot of desoldering. There it is. Okay, so, oops, sorry. Remind me to get things in frame. So, these two guys with the little mark on there. This one here. Oh, we got 1,000 microfarads. Can you see that? Let me bring it closer to you. There we go. 1,000 microfarads at 10 volts. Probably on a 5 volt rail. Yeah, of course. Another 1,000 at 10. All right. So, let's put them on the meter again. So we're set at 1,000 microfarads. Oh, it's actually reading 1,000. Okay. Maybe these are not as bad. But you know what? They're out of the circuit already. You know what that means. They're going to get replaced. 1081. Okay. Let's just put these to the side for a moment. I want to look at these other capacitors. Was it those or these? Remind me. Ah, yes, it was these two. Okay, so we have these 470 at 25. Both have bulging tops. So this ought to be interesting to see what it reads. Bit of fur on there, but that's no big deal. Yeah, 224. So that's half the value that's supposed to be. I'm going to put these on the other meter that you may or may not have seen before. 320 something. Okay, so let's get this out of here. And we're going to go to the fancy programmed meter. If I haven't made a video about this, you will see one soon, and I'll give you all the technical information on it. I'm going to forgo that right now because I don't have it all memorized. But I have used this in other videos. So we're going to see what this says. Ooh, ESR is a little high on this. Oh, 308 microfarads at 4.8 voltage loss. 4.8% voltage loss. ESR 1.1. Not good. Should be, ESR should be like 0.03 or 0.02. It shouldn't be 1.1. Let's see what this one reads. 2.3%. And the 190 microfarads. This one was bad. Look at the V-loss, 8%. So, not good. All right, let's check these other little guys. This might give a little bit more revealing situation out here. So let's try it. 1,051 microfarads, 2.8% voltage loss, 0.45 ESR. Not as bad as I would think. So it could be that I could have left those in the circuit and things probably would be all right, but they're out, so I'm going to replace them with good caps. 0.34. Yeah. I don't like when the ESR gets above or close to 0.5. Don't like it too much. Let's replace those. So those are 1,000 microfarads. I know I have plenty of 35 volt thousands. I should also have 16s. Let's scoot around to my drawer over here. Capacitors. These are all 1,000 microfarad. And I've got a lot of 35 volters, so I do have a few. Well, no, that's 10 volts. Never mind. A few lower voltage ones, but they're just a bit too low. I'm going to need to order some 1,000 microfarad at 16 volt. That would probably be a good option to have. And I'll make sure that they're just a tad bit smaller. I'm gonna have to wedge and jam these bad boys in there. Now, I am looking here, just to, if you can see, the camera can get a shot. Okay, where's my tweezers? My tweezers that I was using as a pointer. Damn it. Well, they vanished. Okay. I'll use this. Oh, here they're there. So if you can see here, there's 3 of these. These are diodes. These are bridge actually half wave bridge rectifiers, since they're coming in from 2 directions and out to 1. So coming in from this side, coming in from this side. The center pin is the output. That is what's hitting the capacitors. There are 3 of these, so probably this one is hitting this pair of capacitors. This one's probably hitting this guy. This one's probably hitting the 2 that I have yet to put in here. And then, who knows, probably getting filtered down into these other guys as well. So, the technique that they use in these a lot of times is, well, what they should be doing is they should be putting the filter choke first and then hitting the capacitor. But I've seen them do it where they go, the circuit will go to the capacitor first and then through the filter choke, which is not the way I would do it. Forgot about him. Believe it or not, sometimes little capacitors that you may think are not doing much can be the source of great trouble if they're not at the value they're supposed to be. This little guy out. See what its value is. And it is a 47 mic at 50 volt. So let's just throw it on here and see what the box says. .7 voltage loss, 0.13 ESR. Well, I think we could do a little better than that. So, 47 at 50, eh? Let's see what we can find. Well, again, slightly higher value, much bigger capacitor. 47 out of 100 microfarads is what we're going to use. Probably one of the few people doing these Samsung repairs that replaces all the capacitors in this little circuit. I'm not even charging over $100 on this. So there is a spot where it was mounted. How did they do that exactly? Is it here? Where did they mount this thing? Ah, there we go. There we go. Check signal cable. So I think I wasn't listening to the chimes properly. That one is off. And this one, I guess I have to wait a second, is on. And there's in the upper left corner, HDMI 2, check signal cable. I don't have anything plugged into it right now, so I'm not going to be able to check that. But the fact that this is on here is very encouraging. Hit the menu. So a nice little menu going on here. So the fact that we can see this and hear, well, we didn't hear the sound, did we? We're going to have to hook up a DVD player and see how things look. If I can get this stupid phone to stay in place. Okay, so there. Let's turn this off. Let's do this again. Okay, so here I am, yours truly. You can see me in the reflection. Finally, he's been revealed. Alright, I'm going to hit the power button. Can you see that down? Okay, right now it's on, but the set is off. So I'm going to hit power. Blinks. Ooh, makes a cute little chime. And check signal. Well, the fact that we see this is a good sign. Let's hit the menu button. Look at that. We have a menu. So I'm going to stop the video for a moment and hook in the DVD player, which has an HDMI output. Okay, so found myself a DVD player. An old garbage find. My favorite kind. Which of course has nothing wrong other than it has no remote. Oh, okay, so anyway, there it is. The machine is playing. The TV sees it. It looks pretty damn good too. I don't say so myself. So replacing all those capacitors, well, it might not have been necessary, but it sure as hell didn't hurt either. Because don't mind the little herringbone pattern you see there. That's not on the TV. That's just because of the phone getting confused a little bit with the signal. But yeah, it's looking just fine. Even this cheesy anime stuff is looking good. You always do want to let these things cook for a little while. You know, you just run it for period of time. I'm probably going to let this thing sit and run for about an hour at least while I go do something else. Maybe get a bite to eat or something to drink. Maybe a little of both. So I'll check in with you folks later. Alright, and so that's it. So, thanks for watching. This is Joe from iRepair Electronics.